Okay, so this video is going to be on lesson 12, and lesson 12 is going to be walking us through finding the inverse trig functions. But before we talk about inverse trig functions, there's actually a lot of information that we need to know that we'll be tying together from previous units. So I'm going to be talking about a few of those topics that we're going to need to know for this lesson, and that's going to be from Unit 5, when we talked about inverse functions, and then we talked about this idea of invertibility. So whether or not our function has an inverse function. So I'm going to do a quick review of that, and then if a function is not invertible, then how can we find the inverse function? One of the solutions was restricting the domain. So these three concepts we're going to be using and tying in with a few things from Unit 6. In particular, what we need to know from Unit 6 is being able to solve for values of the unit circle. So I know that some of you guys may be able to draw the unit circle, figure it out using the triangles, but at one point we're going to need to know the values of sine and cosine a little bit faster. So for example, if I just asked you for the sine of 30 degrees, you should be able to visualize the unit circle in your head and the triangles and say, hey, I have a triangle with 30, 60, 90. Across from that 30, which is my height, is 1/2. So sine of 30 is 1/2. Well, what is the cosine of 3 pi over 2? 3 pi over 2 is at the bottom of my unit circle, and the coheight at that point is 0, so 0. And what about cosine of 3 pi over 4? Well, 3 pi over 4 is here on the unit circle, and at that point my coheight is negative root 2 over 2. So hopefully the values are coming by to you a little bit faster, but if they are not, make sure you go back and review the unit circle. So now, in this video in particular, I'm going to be focusing on reviewing these three main topics, because without these three main topics, this lesson 12, will not make a whole lot of sense. So let me go ahead and talk about inverse functions. So what are inverse functions? What are inverses in general? Well, inverses, if you remember back, is if we have a relationship of points. For example, a function f of x with a bunch of x values and f of x values. So say, for example, my input, I have 0, 1, 2, 3, and for my output, I have random numbers like -3, 7, 5, 8, like that. And I asked you, well, what are the values of the inverse function of x? So f inverse, which is f -1. So what is the inverse values of f? Well, what happens is the input and the output just switch. So now if I input -3, f inverse of -3 is 0. So my input and output values have switched. So f inverse of -3 is equal to 0 because f of 0 is equal to -3. Because f of 0 is equal to -3. So similarly, all my other values are also switched. So if I input 7, I get 1 back out. Here I input 2 and get 5. So if I input 5, I get 2. Here I input 3 and get 8. Here if I input 8, I get 3. Okay, so all my x and y values have switched. So those are what inverses are. Now when it comes to equations, for example, I have an equation y is equal to x plus 3. You might say, well, how do I find the inverse function of that? Well, number one, I switch my x and y's, and then I solve for y. So that means my inverse function is here, x is equal to y plus 3. I'm just switching the values x and y, and then I solve for y, so I minus 3 on both sides, and I get y is equal to x minus 3. That means this equation right here is the inverse of this equation here. They are inverses of one another. So that is a general idea of what inverses are. And when we talk about invertibility, we have to make sure our inverses are functions. So how do we know if they are functions or not? Remember back to Unit 1 when we talked about functions. Functions means that for every one input, there's only one other output. So this would be an example of a function. An example of not a function would be if we had x, g of x, and I had 0, 1, and then 0 and -1. Here I have two of the same input, but my outputs are different. That is not a function. Okay, so my question is now this invertibility. If a function is invertible, that means its inverse is a function. If it is not invertible, then its inverse is not a function. So how do you test if an inverse is a function or not? Well, one is you can find the inverse itself and then test whether or not it's a function, and that's by using the vertical line test. So vertical line test tells us whether or not a function is whether or not something is a function. Function? Yes or no? Whereas a horizontal line test tells us, sorry about the bell. Okay, so whereas the horizontal line test tells us whether or not its inverse is a function. Okay, so that is a test of invertibility. Now, here's an example. If I have this parabola here, this parabola right here passes through the vertical line test. So we know it is a function. Function, yes. But is its inverse a function? Is it invertible? And now I'm going to use the horizontal line test, and I notice that it passes through at 2 points, therefore it is not invertible, its inverse is not a function. So I'm actually going to cut this video a little bit short. I'm going to talk about my last point, which is called restricting the domain. And once I come back to this topic, I'll be able to jump straight into finding the inverse trig functions. Okay, so I will come back in the next video. Make sure you watch all of the videos in sequential order.